All right, Precal12. This is our review session. Hopefully you're having a great last few days prior to taking these exams. We are going to get started with any questions. Right now I've got Trey, Zach, Catherine in the house. There might be more that come later, but right now we're just going to get started on some problems I feel like we would struggle on if we were to take the exam tomorrow. So let's do this. Let's get cooking. What we'll do, let's start on the end behavior. You'll notice on your formula sheet that I put online that end behavior has a couple of things that's associated with it, all right? First thing is when we look at the formula sheet, you'll notice that we refer to two different things as n and a sub n, meaning the actual value that's in front or the highest degree. If the highest degree is odd, there are two different things we have. So let's say n is odd. And we also have where n is even. Okay, then we also have where the lead coefficient is positive and where the lead coefficient is negative. So let's take, for instance, and I think there actually was one on there, but we'll just throw one out there for right now. 6x to the third minus 3x squared plus 2x equals f of x, all right? Now what's the highest degree? Yeah, 3, right? So n equals 3. What is the lead coefficient? Is it positive or negative? Exactly, it's positive. So if it's positive and odd, you know that as you look at it, you're actually going to rise right and fall left. If n is odd and it's negative, you just switch them. Fall right and rise left. Okay? If n is even, both go up, both rises, and both fall if they're negative. Okay? Now, does that make sense? If the highest degree is even, think of it as a parabola. If the highest degree is squared, both go up, right? If it's positive, or if it's negative, both will end up going down. So that's the lead coefficient test there. All right, questions on that? All good on that one? All right, that was the first one. I thought, hey, if we were to give that one, that was probably one of them. Okay. Another one is kind of related with Pascal's triangle. So let's give. I know you have stuff on your review, so I'm just going to throw stuff out there that's not on your review. Hopefully, that's just different that you can use. We'll talk about the review in a second. Let's say 2x minus 3y to the fourth. All right. Now, there's a couple things we can do with that. We can say expand. Or we can say find the third term, right? So I'm going to teach you how to do both. Let's do this. Let's first try to expand it, okay? So if I were to expand this, we know Pascal's triangle has this. And again, I'll give this to you on the formula sheet, right? Good night. You scared me. Hello, that's Sam. Hello, Sam. That's right. We're going over. We just started. Yeah, I sure am. Yes. This is good stuff. So we know the fourth power will be correlated with what? What numbers?
4, 6, 4.
Yeah, so 1, 4, 6, 4, 1, right? So if we have 1, 4, 6, 4, 1, what happens is as we go from left to right, the x starts and decreases, right? So x will be to what power here?
4.
Good. What would it be here?
3rd.
Here. Yeah, and x, right? And where x decreases, y will increase, right? So we'll actually end up going from right to left. So y to the fourth, y to the third, y squared, y, and then nothing. Okay? Now, if I was saying, hey, do this, just find the third term for me. Now, what would be the third term?
6x squared.
That's exactly right. So all I need to do is focus on that. So I'd pull that out over here on the side, 6x squared, y squared. And what would be plugged in for x? And if x confuses you, you could actually use a and b, right? Remember, a would be the first one, right? B would be the second?
2.
Yeah, so 2x would go in for, I know it's kind of confusing when I say 2x goes in for x, but that's the first component, right? So 2x goes in for x. We're going to square it. And what goes in for the y here?
3.
Yeah, negative 3y. Very good. So 2x squared gives me what? Good. Okay, so we have times 6. And negative 3y to the second would be,
negative 6y squared.
be careful, squared, right? Y squared's right.
9y squared.
Good. And then we keep it positive because negative 3 times negative 3 is 9. So 6 times 4 times 9 gives me what? If you need to, you can kind of take out those calculators a little bit. My handy dandy phone calculator.
I lost mine.
You know you're a math teacher if you have a phone calculator that you bought, like an app you bought. Kind of geek
I
thing
feel
to
like
do.
anyone could buy that. It's not like exclusive to teachers.
True, but yeah, you know you're a geek if you have. Yeah, so I've got 216 x squared y squared. Okay. All right. What's up, Maddie?
Hey,
Good to see you.
good to see you. Here. I have to go to an AP Gov help session, but I'll be back maybe. I don't know.
Thank you so much.
Of course.
Appreciate it.
Yeah.
That made my day.
Are you going to AP Gov?
Yeah, I probably will
Yeah.
later.
Cool.
So I'm podcasting,
What time
so
is it?
too.
Awesome.
So
Cool. I think like 6. Yeah.
y'all, what time does it start? Now
AP Gov?
till
No,
perfect.
till 6.
Perfect.
But I'll be here maybe later.
No problem, Maddie. I'll post online.
Okay, cool.
See ya. Sorry for that little fiesta. Is it siesta or fiesta? Like a
The
little break.
Fiesta would be a party. The siesta would be a break.
That we could have
So
both.
It's kind of both.
Both?
Fiesta, siesta.
Let's have a siesta. All right. Yes. So. Whatever, so
We've been with Coach Johnson for too long.
Yes, this is just too long. It's time. It is time. So what you could do to find that third term is just use what the third one is and plug it in and go from there. Okay. One where you actually have to distribute out might be one. I probably won't go to the fourth. I might go to like the third, right? It could be something where like say 2x minus 3y to the third, or maybe it might not be as long of a process, but within the term, when you expand it, all you would do again, the x you'd plug in the first term, for the y you'd plug in the second. Make sure you include the sign. Okay. Do you need me to show you how to expand that out, or does it make sense?
What did we just do just now?
We just found what the third term was.
Okay.
What I'm saying is that expanding is the same thing. All you're doing is finding, in this case, the first to the fifth, right? Right? Because this has 1, 2, 3, 4, 5. You're doing the same thing, except you're not just finding what the third term is, you're finding all 5.
Okay.
Okay? That makes sense?
Yeah.
Do I need to go through that, or does that ring a bell?
Can you go through it?
Yeah, absolutely. Okay. So right now with the x to the fourth, I plug in 2x, right? So what I have now is, and I know I'm going to run out of room here, but
So it'll be
2x,
2x to the fourth.
correct. So 2 to the fourth would be 16, right?
Right.
So I'd have 16x to the fourth would be my first one. The second one would be 4, and I'll put it up here, the work. 4 times 2x to the third times negative 3y, right? 4 times 2 times negative 3 gets me?
So it'd be 8x to the third
Mm-hmm.
minus 3y.
Yep. So weight's 8 times negative 3?
Negative 24.
Good. We just did the third one, right? 216. X squared, y squared. The fourth one would be 4xy to the third. So we could do 4 times 2x times negative 3y to the third. Okay. So negative 3 to the third power would be negative 27. Negative 27 times 8 gets me 216. Just happens that it's the same thing. So it'd be actually negative 216 xy to the third, right? Are you with me so far? So I've got 4 of them. Then my fifth one would be y to the fourth, which would be negative 3y to the fourth. Negative 3 times negative 3 times negative 3 times negative 3 is 81. 81, it'd be just 81y to the fourth.
So you just leave
So
the
this right here.
exponent.
That would be it right there. I know that's really messy, but that's the idea. Does that make sense, Trey?
So even though you multiply the coefficient by the exponent, you leave the exponent anyway.
Correct. Correct. Remember, because up here, right, you have that x, right? Okay. Now, what if I didn't have it? What if it was just 2x minus 3 to the fourth? Well, anytime I would plug in y, I would plug just negative 3 in for y. you would have no variable with a y there. That's what you plug in. So when you refer to x and y in here, it's just the first and second term. Does that make sense? Okay. Another thing that I included that we really need to just talk over real quick is if you remember e to the x, that's a punter. Good to see you, man. We have y equals e to the x and y equals ln of x, right? Remember, e to the x has a horizontal asymptote at 0 that approaches at 0, 1, and then increases, right? Whereas for my ln of x, I've got a vertical asymptote here, and this time it's going through 1, 0. It actually should go right through there, okay? So this is, again, ln of x, and this would be e of x, okay? So what if I did this? Y equals e to the x minus 2 plus 8. That's probably too much. Plus 2. Where would that go? What would happen with this horizontal line?
Shift right 2.
Perfect. So this point right here, right, that normally goes through 0, 1, would go right to up 2. So it should go about right there. And what would happen with the horizontal? What's up, Emily? What happened with the horizontal here?
The horizontal axis or aspect.
Yeah, it'd go at 2, right? Okay, so we would have it, and I know that really looks weird, but it would look something like that, right? So it would literally go up 2 and to the right 2 because of that and that.
So the x minus 2 says up 2, and then the plus 2 says to the right 2.
No, this says up 2, right? With the x is right 2. Because if it's with x, remember, think of it with x, we know it's opposite, we go push it right 2. What do I plug in for x to make it equal to 0? 2, therefore it's right 2. Does that make sense?
Yep.
Where would this one go?
It would go to the right 1.
Correct.
And it go up 2.
Good, so right 1, up 2. So it should be, if it's right 1, it's going to be something like a horizontal will be here, and that ln of graph would look something like that. Okay? On the test, I'll tell you because y'all are here. Okay, I'll just be honest. What I gave you is pictures of a calculator, and I said what graph best represents this.
Nice.
And I gave you different ones, and you just match
So we
one
won't
to
ever
the
have to plot exact points with that.
correct. Just have an idea. And that's why right here, that's very important. If you understand with the ln of x and e of x, where it's crossing, what one point it crosses, and where that one has a horizontal, one has a vertical, that'll be a big deal.
Those of you on the podcast, forget everything you just heard, cheaters. They didn't actually show up to hear that hint, so.
Oh, yes, yes. If you didn't show up, you can't use that hint. So wipe it away from your memory right now. Literally take your – no, I can't say that on this. All right, let's go to the next part. I was going to go, so I couldn't do it. All right, we're going to drop logs now. What we're going to do is we're going to take the next one. Hopefully people don't hear me at home on this one. All right, so what about this one? ln of the cube root, or the square root, I'm sorry, of x cubed over y. If I say expand this, and again, this was number 6. I think, Catherine, you had a question on this one. How could I expand this? Well, first of all, you know 3 rules, right? And I gave you those 3 rules. We have multiplication, we have division, we have the power rule, right? We have those 3. So real quick, what could I do with this to really expand this out? Oh, that's a good start. That's a good start. Say that again. I can. How can I do that? Yeah, this is the same as the 1/2, right? So what do I take with 1/2? Shoot it to the front, right? Because that's the power rule. So right now we have 1/2 ln of x to the 3rd over y. Well, what do I do with that now?
Can you distribute that ln to both of them?
It will, but because of that division, what will that?
Subtraction.
Exactly.
X to the 3rd minus 1. Ln 1.
And it's got to be the same thing, right? 1/2 ln of y, because the 1/2 ln goes to both. Good. Anything else?
Celebrate.
True. other than celebrate. Celebrate good times.
Two,
Come on.
2 times, yeah.
Shoot that 3 to
over
the,
2.
yep, shoot that 3 to the front, right? So it should be this right here, 3/2 ln x minus 1/2 ln y. That right there is your answer.
And would that be multiple choice 1, 2, where there's even options on what the
Yes.
extension is?
Okay, fine. You want more hints? I can give you more.
I'm just checking on format. It's not really in. Yeah, you know how to do the math. I don't know how to do the math. You know how to do the math.
I have five fill in the blanks. You ready for 5 fill in the blanks? You ready? Number 1, expand the binomial, what we just did. Okay, the one we Pascal's trying. 1, simplify by giving the operations with an imaginary number, knowing how to multiply out. Okay.
Can you repeat that one time?
Yep, binomial, expanding a binomial, right?
Yeah.
Pascal's triangle. Second, simplifying by multiplication with imaginary numbers. I squared equals.
-1.
Square root of -9 is.
1. No.
Square root of a negative, it's hard to see, I know.
You said -9.
Square root of -9 is
3i.
3i. Okay, knowing that's important. Next one, knowing some of the rules for like the logs, which cancels out, what can you do? Knowing that if you have log base 7 of 7, right, that those cancel, giving us 1. Those few things are important. And then 2 more. 1 where you have to figure out, tell me what are the vertical asymptotes, horizontal asymptotes, what's the whole, and then slant asymptote would be bonus if there is one. Okay. And the last one is solving for the hyperbola, actually graphing it, telling me all of those things about it. I give you the equation, you tell me all the rest of the stuff. So I just told you the
I got a
5
copy
fill
of
in the
that.
blanks. Yeah. If you want to just slip me a couple thousand underneath the table, and we'll just,
1,000.
hey, it's expensive. Come on now. It's expensive. Put my job online. Can't believe I just said that on the podcast. All right, so please don't put money underneath my desk. Please don't. Yeah, please don't do that. That would not be good. All right, so so the next one, we did Pascal's triangle pretty good. Okay. Do we need to come back to hyperbolas and ellipses? Can we come back to that one? We'll do that one at the end. Was there one on the sheet that had domain and range? Felt like there was on the review. Was there one?
That's a very good question.
Thought domain there was one.
Do you know what unit it would be in?
So I'm looking at. I'm trying to see.
But just download one online, and there's a bunch of them that are highlighted. Is that anything? They're highlighted?
No, that doesn't mean anything at all. Maybe ones that I thought could have been some struggle areas and whatnot. Which one's highlighted?
The projectile one, polynomial function in standard form.
That's it. Yeah, just ones that I felt like might have been a struggle or might be a struggle. So we're kind of going through some of those together right now. Let's do this one. What about, let's do this one as a domain and range one. X squared, and this is number 3 on section 1. Number, did I say 3? No, I think it's on section 2. I'm sorry. Section 2. Yes, section 2. All right, so here's the problem here. And what I'm going to ask you is, what is the domain of this? Now I'm going to do this. Let's just for a second, let's try to get an idea of what the picture looks like. So let's come up with our VAs, and then this is kind of practice for the other stuff too. HA, holes, and is there a slant asymptote? I don't know, but we'll figure it out, okay? So let's do this. Let's first solve this by factoring out. So what would the top factor to be?
X plus 5 minus 3.
Good. X plus 5, X minus 3, right? Okay, what would be the bottom?
3, 4, -3, -4.
Nice. X minus 3, X minus 4. Nice. So do you see anything that you could know right off the get-go, like VAs, holes, HA, anything that you... Okay, holes at 3. Why do you say that, Kath? Good. So if the hole's at 3, how do I find what the y is? We plug it in without what I canceled out, right? So cross this out. That's done. But the 3, if I were to plug in, would be what? What would I plug in for this?
8.
Okay, 8 over?
-1.
8 over -1, or we just say -8. So 3, -8, there is a hole. Okay? The hole in the bottom of the C. Hole in the bottom, right, remember that?
Yeah.
I'm sorry, how did you get the -8?
I'm sorry, I got thrown off.
You're good.
Yeah, so 3 I plugged in for the x without the x minus 3 that I canceled out. So I take out how I got the hole. If I plug it back in, 3 plus 5 is 8. 8 over
Gotcha.
3 minus 4, which would be
You plug
-1.
in the X. Got it.
Correct. And that's all I'm doing is just plugging that 3 back in. Now, you know anything else here that you see? Vertical asymptote, horizontal?
Rule the terms are it's both x at first of those, so wouldn't that mean that how you find horizontal?
Yeah, so since they have the same power, same degree, what can I do with that? I think I ended up putting that on here for sure. I'm almost positive. Yeah, it's the rules right here. If n equals m, then the line y equals a over b is an asymptote, right? Meaning we would have to divide out x squared over x squared to get us what? 1, right? So the horizontal would be y equals 1. Because the degree is the same, we take x squared and put it over x squared. If there was like a 2 here, we would put 2x squared, right? There's not.
So it'd be 2.
If it had a 2 there, you're right. But it doesn't. So because of that, these cancel, giving me
What if the degrees were different?
degrees were different. If it's higher on the top than the bottom, it'd be none, right? Okay. If it's higher on the bottom than the top, it'd be 0. Okay. And if the top is greater than the bottom by 1, then you have a slant asymptote, right? Remember I told you it's possibility, so I put it in there that it's a bonus if you were able to find that. Okay.
So if the bottom is greater than the top, then it's 0.
Correct. Top's greater than bottom by 1, slant asymptote. And it would be none for horizontal. You can't have a horizontal and a slant. It's either one or the other. Okay? That doesn't mean if you don't have a horizontal that you have to have a slant. Does that make sense?
Neither or just one or the other. You can have both.
Correct. That's exactly right. Any vertical asymptotes? X equals at all?
Is that where we solve for set each one individually to 0?
Okay, which would be?
So -5 and 4.
Be careful. We don't need the top. The top can be 0, right?
It's the bottom.
Just the bottom, right? We don't want it to be
So
undefined.
it'd be 4.
Correct. X equals 4 would be my answer. So is there a slant asymptote here?
Sure.
Nope.
Okay.
Absolutely not. The reason why is because we have a horizontal. If the horizontal was none, meaning that it was greater on the top than the bottom, and the top was greater by 1 degree than the bottom, then you can have a slant. And how do I solve for the slant? Divide the bottom into the top. Okay?
So you said you solve a slant by the only time there's going to be a slant is if the top is higher degree than the bottom.
Let me give you for instance. How about that?
Um,
What's the degree of the top?
3,
3. Good. What's the degree of the bottom?
2.
Okay. So if 1 degree higher than the top than the bottom, is there a horizontal? No. Okay, because it's higher on the top than the bottom. If it's 1 degree higher on the top than the bottom, then you're testing now, you go for the slant asymptote. There.
intercepts. How can we find those?
Intercepts, great question. Anytime I'm solving for an x-intercept, I plug 0 in for y.
Got it.
If I solve for an x-intercept, I plug 0 in for, or I had said that the opposite. If I solve for x-intercept, I plug 0 in for y. If I solve for a y-intercept, plug 0 in for x.
So like with this one, we plug 0 in for x
Correct?
up top, and if we do it on our simplified one or on our first one?
Simplified one.
Okay.
Mhm.
And all right.
Because if you didn't do it, it'd be 0 over 0, which is undefined.
Then like when you plug 0 in for y,
Mhm.
on the other side, doesn't that get complicated because you have all those x's? You got to combine them back together.
Oh, if I plug 0 in for y, well, it's only where the top equals 0, right? Think about it. If I plug 0 in for y, right? If I plug 0 in for this is what I have. I'm only looking for where the top equals 0. You've already factored it, right?
Got it.
So it'd be -5. Well, and this wouldn't be an intercept because it's already whole, so -5.
Okay.
So you
Makes
do it
sense.
in the equation with the holes taken out.
Correct. Correct. I think I'll look at the test in just a second. I'll let you know. Oh, you know what? Great example is number 5 on unit 3. I'll look at that one in just a second. So the one that you were talking about, X and Y intercept, unit 5 or number 5 on unit 3, we'll look at in just a second. In fact, that was the next thing. All right. Okay. So with this, we have a couple things. Horizontal asymptote is at 1, right? Okay. Vertical is at 4. You might say, well, why am I doing all of this for domain? Again, you don't have to. I'm just showing you. Okay. Just showing you. That's it. I have a hole at 3, -8. So I'm going to have a hole down yonder somewhere. It's going to be a hole in the graph. And so obviously something's going to look like this. Now, do I have to know specifics? No, not right now. If I told you to graph it, it'd be nice for you to plot a couple points and see. But it's not necessary as far as right now for domain. If I said find the domain. But think about it for a second. What would be my domain? Remember, domain's left to right. Negative infinity to sure. So that means it's continuous from negative infinity all the way to 4.
Negative infinity, positive.
No? It is stopping at 4, you're right, but it's stopping somewhere else too.
Oh, the hole.
The hole, right?
Go to negative,
So it would be, again, we're just looking, not negative 8. Remember, domain is just on the x-axis,
So
right?
it'd be negative infinity 3.
Perfect, that's 1. What's another one?
3 to 4.
3 to 4, good. What's the third?
Third one?
4 to? Nice, Z, good.
Does it go
4
past?
to infinity, right? Does that make sense?
Past the 4. I thought since the asymptote stops, it would stop.
It does stop. That's why we have to stop, stop the domain. Does that make sense? But it picks up after 4. So you can't just say negative infinity to positive infinity because it's breaking up, right? You have to go at each stop. So negative infinity to 3, that's my first stop. 3 to 4 is my next one because it's a vertical asymptote. Different. Okay, one's a whole, one's a vertical. Still the same thing. Then at 4 to infinity, it's continuous, right? It goes all the way. So what you have is all 3 of these, right? On the exam, this is how it will look. It'll be multiple choice. I've seen it. This is how it will look. You'll be just like this. Okay? So right here, all 3 of those, you're just going to have to be aware of. Now, do you have to graph that? No, not technically. Would I? I would. Okay, I would. I just would, because that would help me. When I get all 3 of these, that will help me to determine what that domain is. Really, what are the only things that matter with domain? My vertical and my hole. But I just wanted to make sure I went through everything just in case. Okay? Does that make sense, y'all? Word. That makes sense, Hunter? Okay. All right, the next one, number 5 on unit 3, that's a really good one, okay? If Caleb was here, I'd say, well, I can't say on the podcast. We'll just leave it at that.
He's probably the one watching.
Yes, he is. He's probably watching right now. He's probably, Mom, hey, look what Coach Jay said,
He's going to call us in a second, telling us why.
That's right. That's right. All right, so this asks, what is x-intercepts and y-intercepts? Okay, let's review. X-intercepts we plug 0 in for.
Why?
Good. And at y-intercept we plug 0 in for. Okay, good. All right, so that right there is key to what we're trying to do, okay? That's not on a review anywhere. That you just got to know that. So if I plug 0 in for y over here, this is what I have. 0 equals 2 minus ln of 3x minus 9. We'll look at that in just a second. That one's a little tougher. The next one is a little bit easier. We have g of x, or y, is equal to 2 minus ln of 3 times 0 minus 9. Now, 3 times 0 minus 9 gets me? Yeah, so what's the ln of negative 9? Really, what's 2 minus ln of negative 9? I'm going to go out there and say that ooh, that's nice. 5.463. Good. Okay. Also, question, does it ask for something else in that? Does it ask for like what type of shift or anything? Okay. All right. Now this is a little different. You just got to kind of think a little bit. Okay. Remember, ln traditionally has a vertical where? Like, remember the graph, right? Remember the graph we showed at the beginning? Where's this graph going to approach?
The y-axis.
Good. It's going to go like this, right? Remember that? In fact, I gave that to you on the formula sheet, like what the picture would look like, that this is ln of x. I tell you that, okay? Just in case, remember, e is this way. So if it's traditionally here, I've got to see if I plug this, remember this is transforming it left and right, correct? So that's what's changing my vertical asymptote. So if you think about it, what could I plug in for x to make this equal to 0? 3, right? So where is this vertical going to go to? 3 to the right. 1, 2, 3. And it's going to have a new one here. So what you would say is vertical is at x equals 3. I don't think that that's going to be a huge one on the test, but I don't want to say no and something like that was on there. So I want to make sure I include that. It's not x or y. It's totally separate. That is just my vertical asymptote. I guess.
Vertical, that's what I meant.
Yeah, vertical asymptote. That's it. It's not an x and y intercept. It's not crossing. It's just what it's approaching, but not coming close to. Remember, asymptote creates a infinite crack in the graph that will approach but never cross. Okay. All right. What's hilarious? I finally broken y'all because I can say it without y'all laughing. You're just like,
No,
it just happens, you know? Well, there's YouTube followers in England that are saying,
Oh,
English.
is that how English people laugh?
yeah. I didn't mean that. No, I didn't mean that. I make sure those that are English, I'm sorry about that. I'm sorry out there.
You haven't broken us because we still won because we got you to get on top.
True. Yes. You didn't even say anything. Right? Anyway, so on this one, what could I do to solve for x here? This is the tough one. The y-intercept is the tougher one. Very good. Nicely done. Roxanne?
Sorry, I was copying you.
Yeah,
What?
you're gonna move your 2 over.
Correct. We're trying to solve for x, right?
So move your 2 over.
Good.
All right.
All right, what can we do now?
Math.
Distribute what?
Negative L.
You can't do that.
Well, you can make it
Because ln is-
ln of 3x over negative 9. Can you do that?
Ooh, it's actually a good thought.
Over 9.
Yes.
That's a good thought if ln was with 9.
It's not with 9.
Because ln is applied to all of this, right?
Yeah.
Remember, this, what's up, Chris?
Oh, I got you. That's different.
Good to see you, dude. This right here is different than that, right?
Yeah.
3x minus 9 is all 1. Okay, so what could we do? Well, we could take away this negative,
E.
right? That's actually pretty good. Take away this negative first to make it 2 equals ln of 3x minus 9. What's the kryptonite to break away ln?
E.
E, nicely done. E ln, cancel, little cancel party. E squared equals now 3x minus 9. So how could I get rid of that? How could I solve for x now?
Plug in
Find out what E squared is.
E squared. Yeah.
Yeah, you could do that. And then what would you do once you found e squared?
And I have to divide by 3.
Bingo. Nicely done, Trey and Chris.
And
Okay.
that'll give you in total 5.46.
5.463. 5.46. Now, actually, they're one and the same, aren't they? Did we do one and the same?
Mhm.
X equals, hold on just a second. I want to come back here. 5.463 comma 0 would actually be the correct answer. One thing I wanted to do when I came up here is the y-intercept. Did they ask for the y-intercept? I don't think they did they? I don't think they did. We actually already did it. I want to make sure of it. 2 minus ln of negative 9. Let me actually include this here. In fact, I think if I was right here, yeah, in fact, you can't take the ln of negative 9. Okay, do you see that up here? We did this correctly, but we can't take the ln of negative 9. So actually, there's none in terms of my y-intercept. There's not one. Okay, there's not one. Does that make sense? You see why? Because if I transformed it to the right 3, where's this going to be? Well, it's going to be right here. Does that cross at the y-intercept at all? No, you can't take the ln of a negative number. And so actually, this right here that we had talked about, I was actually looking at the answer key. This is nothing. This is actually going to be none. And so if you put this in your calculator at home and you're yelling at the screen like Dora the Explorer, you're exactly right, because 2 minus ln of negative 9 cannot happen. Okay? All right. Swipe or no swiping. Next one. Holes in vertical asymptotes. I think we already went through that, right? We're good there. We can go through another one later if we really have to. One that I wanted to look at was, oh man, this one's good. This one is amazing right here. I think it is. It's one where you find the zeros using your calculator. Do y'all know that one?
Is that where you just trace?
Yes. Number 2 on unit 2. Gotcha. I don't think you can do that, but that's okay. How dare you go to the restroom when you're a senior and it's 4 o'clock in the afternoon? You don't even have to be here. How dare you? F of x equals x to the 4th. I'm joking for those of you in England. X to the 4th plus 10x to the 3rd minus 10x squared plus 5x minus 66, okay?
Wow.
All right. This one's pretty big. This is a beast one, okay? This is a beast one that I just do.
Y equals there.
There we go. Yeah, so on this one, what we want to do is find where it crosses the x-axis, all right? Now, this one, I'll tell you, this one's probably the toughest one. If I were to say toughest one, it would be this one right here, okay? So let's quickly go through it, see if we can, when we go through it, if you have questions, let me know, okay? Are there any questions on how you would plug this in?
You go to the y equals, right?
Correct. So I'm going to plug in x to the 4th plus 10x cubed minus 10x squared plus 5x minus 66. Okay? All right. Now, when you hit your, when you go to your zeros, do you remember how to do left bound, right bound? Remember that?
Yeah.
Okay, remember go left bound if the graph, and I'll actually put out what the graph looks like approximately. So here's what we've got right here. We've got this graph. We've got, let's say this is negative 10. This graph actually comes through this way. So it should look like this. Then it comes down through here. This is what the graph should look like, right? Make sure with right bound, you go like to the, I'm sorry, left bound would be to the left or above, whereas right would be below. Just make sure one's above, one's below, and then guess in between, okay? Same thing here. Left bound would be below, right bound would be above, and then when you guess, you're going to try to guess right on top of it. If you don't do that, it'll have like a syntax error or something. That just means you did it incorrectly. It's not, I mean, I'm not going to give you one that you can't do, okay?
So you do both sides, even if negative and positive?
Correct, because you want to get both zeros, right? Now, when I did it, I'll tell you, unless someone has a question on a calculator, how to use it there.
You just find zeros.
Correct, that's it. But I got 2. I got negative 11 and 2, okay? Now, how many more zeros could I possibly have? How many more solutions can I have?
2 more.
2 more, because why?
Is your highest? 4.
Exactly. Remember, parabola can have upwards of 2 times it crosses the x-axis. So because of that, we could have a possibility of 4. So we're going to test just to see what those solutions are. So let's use negative 11. What am I going to do with negative 11? Here's a hint.
Synthetic division.
Oh, yeah.
Bingo. So we're going to start with this one. See, I told you it's a little bit of a beast. This one's a little bit of a beast here. I don't think synthetic's tough, though. Am I wrong?
No.
I think it's too bad.
I get it wrong sometimes.
Well, one good thing is if you don't get a 0 at the end, what do you know?
You know you didn't do it.
That's right, because you got to have a remainder of 0 in order to know that it's a 0 that is a solution. So I know negative 11 is. What do I do with this next part? What's left over?
Just you go from
Put the 2 in.
Yeah, nice. Nice, Chris. So we can plug the 2 in, right? Because that's the second one. All right. Got it? 0. And we know this is a 0, so we're good. So right now we have 1, 1, and 3. What really is that? What is that? 1, 1, 3? What could that be transformed into?
X squared plus X plus 3.
Perfect. Can I factor that? I don't think so. So what are we going to have to do here?
Quadratic.
Bingo. Yep. And so x equals negative b. So I'll plug it in. Negative 1 plus or minus the square root. 1 squared minus 4a times c all over 2a. Okay? So now I've got negative 1 plus or minus the square root of 1 minus 12 all over 2. So I should get negative 1 plus or minus the square root of negative 11 all over 2. What is negative 11? Remember we talked about this one? Yeah, there we go. Negative 1 plus or minus I squared of 11 all over 2. Those 2, including negative 11 and 2, are my zeros. Now, is that a beast? Absolutely. What's the good news? Well, the good news is that it's multiple choice. So if you're able to actually look at that and say, oh, man, I could show work. If you show work for me, I could possibly, I'm not sure how this will work, possibly go back and check and give you points back on that. Okay? So please show work, all right? Throughout that whole thing. That's at home too. Show work throughout the whole thing and tell everybody, remind everyone from there, okay? All right. You're good, man. Absolutely. I'll put this online. I'll put it right at the top of the intro page, okay?
Thanks.
Anytime, man. Okay, I think that the projectile, okay? I had 2 more, and then you're good to go. If you have questions, ask me. Then we'll go from there. Can we look at the first one? All right, the first one says, what's the equation on that one again? Is it?
First one, the very first one on the review.
Yeah, first one on the review. Is this it? Is that it right there? Okay. Question 1. It tells us, we ask, what is the maximum height? So how could I find what the maximum is?
Plug that sucker in.
Trace.
Yep, plug it in. And you could trace too. One thing you could also do is if you go to calculate and go to math, calculate, go to maximum, MAX, go left bound, right bound, guess, you could do that as well. You know what I'm talking about, Chris?
Yes.
They could
You know
point
how to
to.
get this,
Yeah, come on.
when we were doing this thing, it's still on my calculator. So we can talk about.
Yeah, let's
You
go
gotta get that
to mode. Sequential. What I would do is this. Let's do this. You don't have anything important, correct?
No.
Let's do this. Let's go.
I just need it set up like properly for the exam to where I'll be able to,
If you ever do it, go to second plus, which is your memory. Just reset that. If you ever have a question about that and you're just like, oh, I don't know what to do. And then afterwards, you can then plug in and then kind of go from there, okay?
I'll start a slow showdown, but
Yeah, absolutely. Go ahead.
how do you do the intersect here? Like, so I went to, you said 5, and then.
Yeah, then go left bound.
So is that the first? This is first curve.
Oh, intersect. Are you
Yeah.
talking about the zeros where it crosses
It was
the?
number 4 on the review on unit 1. Yeah, right here.
Right here,
Yeah,
this one?
This is then find the intersection.
Oh, intersection is like the zeros, right?
Mm.
Where it crosses the intersection. So
Right.
intersection, think about intersection as 2 curves intersecting.
Okay.
On your calculator, that's what it's talking about. When it's
Mhm.
talking about zeros, that's where it crosses the x-intercept. That's what we're
Okay.
talking about there.
So how would you get?
So go back there to that 1
So it's like
and then go to 0.
2,
See
okay.
that?
Okay.
Left bound and then go to right bound
Okay.
and then kind of go from there, okay?
If the review's due, they have the exam, right?
Correct. Yes, sir.
I've got it.
Okay, no, you're good, man.
Thanks, Josh.
Anytime, Z.
I just grabbed,
Hopefully see you tonight.
just grabbed
Yeah,
that
maybe.
and
It'll be fun, man.
nothing popped up.
Yeah, go to Zoom. Go to Trace because sometimes it's outside of it. Zoom to, oh, I'm sorry, Zoom. I'll go, not Zoom Trace. I'm sorry, Zoom Fit. A lot of times if you go to Zoom Fit, that'll fit that graph right inside what you need to. And that'll give you exactly what you need. See how nice that is?
Awesome. Yeah.
And that will give it to you. Then at this point, is this what you got for your maximum? for A?
Then you get to max.
If you go to, and I'll use my calculator to kind of find it. If you go to math, no, not math, I'm sorry. Trying to see it on yours.
Trace. Maybe look at that. Yeah, it's on math.
Is it on math on yours?
And then you go over one to numbers.
Then go to calc. Is it at the top, CALC? I can look at yours. My calculator right now is,
Oh, wait, it's on-
I have it a little bit different.
I went to math, and then you see over numbers, and then max is right here. But I don't know what that means. 'Cause it just-
Yeah, do this. Go to second trace. Okay. That's all right. Plug it in. That's okay. We have time here.
Plus X. All right, so you went to second trace.
Correct.
Ah, there it is. Gotcha.
Then go left bound, right bound, right? And again, those at home, if you're confused on that, this is where we're at right here. Okay, here's this graph, right? This guy's up here. He decides that, oh man, I'm gonna throw a wolf off of this, a baby wolf. I'm gonna throw off the cliff. Okay, a baby like 2 months. Okay, and it's on a trampoline down here. Okay, so it's a trampoline, so it'll bounce up and it'll be safe, I think. So the maximum we're trying to find on this is if we go left bound here, right bound, and then guess on where we think the maximum is, it should give you exactly where the highest point that wolf will go. Okay. All right. Did you see it there, Hunter?
Yeah.
And again, I think
I got 1 point. Can you tell me what you got?
1.56.
Yeah, 5.6, and then y equals 2.7.
Perfect question. How far away from the cliff is it at this point, at the maximum height?
Would it be the x?
Correct, because remember, x is how far away from the cliff, right? And really probably if this is the projectile, right, that goes up, the cliffs is like this. So here's the baby wolf, and there it is. It's coming down, all right? And there it is on the ground, okay? So as we throw it, okay, that's off that cliff, that x is how far away it is, all right? Second thing is what is the highest the wolf will go?
Maximum, right? Or what do you mean by that? You mean like, because it's going to go up a little bit right after it shows, right?
Okay, how you already said how far from the base of the cliff it was. How high will it go?
200.7.
Bingo. Do you see the difference there? Okay. And again, I want to just go through those questions. Third one says, find the positive x-intercept when it strikes the water when y equals 0. So what we're trying to do is find where y equals 0, where it crosses, right? So you can actually figure this out by finding where the 0 is, right? And just like Chris had done earlier, we can find that by plugging 0 in for y. Or you could find it by doing the 0, by going to second trace, go to zeros at the top, go left bound, right bound. And when you figure that out, C will end up being 26.61 feet on that. Again, remember, when you're going up, left bound, right bound, guess, that guess will be 26.61 feet from the base of the cliff, all right, where it strikes the ground. All right. Does that make sense so far? Everyone good? All right, our final thing on D is how far from the base of the cliff will it be if it is 100 feet above the water? So to do this, what we want, we know that the f of x stands for my height. That y stands for the height above the water. So what we can do is say, for D, we can have a new equation. 100 equals negative 0.32 x squared plus x plus 200. Now, how do I solve for where it is 100 feet? Well, if I subtract 100, what I have now is a new equation where 0 equals negative 0.32 x squared plus x plus 100. To where when we end up putting that in our calculator and we solve for the x-intercept, x will be equal to approximately 19.31 feet away from the base of the cliff, okay? So Hunter, does that make sense? I know you're really paying attention just because I know we were talking over this. Does that make sense on what I did there?
Yeah.
A and B, we're good on. C, do you understand how in C we're just solving for the 0? When did it strike the water?
You
How
just go
far?
left, right, guess on that.
Correct.
Zero.
Left has got to be above the exit intercept. Right bound has got to be below, and then we've got to guess in between. Okay. Remember, we're going to do the same thing with this one. The only difference is now the height is 100 feet instead of 200. So if I put 100 in for f of x, what I want to do is then subtract it to know now I've got my new equation, and I solve that. When I do that, again, left bound, right bound guess with the new equation would be 19.31 feet. Okay? All right, I've got one more thing to go over, and then I'm going to open up the floor, okay? I think hyperbolas and ellipses we might want to go over at the end here. The last one is the sum of a geometric sequence. You remember that?
That was one of the scavenger.
Correct. Here's one. Unit 4, number 2. Actually, numbers 1 and 2. Okay? All right. Here's what they gave us. And again, I'll be done with this, and then we can go over hyperbola, ellipses, whatever y'all need. Okay? First term is -7, and the common ratio is 1/3. Now, did they give that to you on number 1 on Unit 4?
Find some geometric sequence.
And did it give anything else?
The number is the -7 sequence.
Yeah, did it give you A sub 1 is -7, R is 1/3?
Yeah.
It actually, did it give you this? -7, 1/3 to the n? It didn't?
I did on number 2, not number 1.
So number 1, it just gives,
The sequence itself.
okay, what is the sequence? I'm sorry.
-7,
Okay,
-7/3,
perfect.
-7/9.
X, I gotcha. Perfect, dot, dot, dot. Okay. So does it make sense that the first term is -7?
Yes.
Does it make sense that the ratio is 1/3?
Yeah.
The common ratio?
Because you just multiply the denominator.
Perfect. Yeah, that's exactly right, Chris. We know that each time we're multiplying by 1/3 to get to that next number. Good. Now, do you understand too how the sum of an infinite series, I put this on your review so you'll have this. The equation for the sum of a geometric infinite solution is listed right here. So literally all we're doing is just plugging in -7 over 1 minus 1/3. That's the sum of an infinite geometric sequence. Okay? So 1 minus 1/3 is 2/3, right? So -7 over 2/3. So I multiply this by 3/2, right? Because I bring it to the top. So 3/2 times -7 gets me -21 over 2. Okay? That's my answer. Now, I probably won't do this, but I want to make sure I mention it. What if the ratio was greater than 1? You remember that, what we talked about? And I said find the sum of a infinite geometric summation. What would you say? If something's infinite, how can you find the sum of it?
With the right equation.
Okay. Think of an asymptote. If it's approaching, right? If it's approaching, right, it's getting closer and closer and closer to, is it ever crossing that vertical asymptote? No, but it's getting pretty close to it. Does that make sense? Same is true here. If the common ratio is greater than 1, you actually cannot do this. So you would say, can't do, or, unable to do, or whatever. I probably won't do that on the exam. Okay, I probably won't do that, but I want to make sure I at least let you know. Number 2, what does number 2 say?
It says, it gives you the thing. It's found sum of the first 10 terms, and an equals 12 to the -1/2, or times -1/2, and then the exponent is n minus 1.
All right.
Rounded 2 decimal places.
Perfect. Yeah, this one, again, same thing. Some of it, is this going to be finite or infinite? Because it's the first 10, right? So we know that. So n equals 10 because that's how many terms we're finding. What's a sub 1? What's the first term?
Oh, sorry.
And I'll give you this equation too. Here's the equation. So what's the first term?
10.
You sure? What corresponds to this in my equation?
Oh, 12.
12, right? Because that's what's first. What's the common ratio? Good. That's exactly right. So here's what I have. The sum of 12 times 1 minus negative 1/2 to the 10th power all over 1 minus
It would be 9.
negative 1/2.
N minus 1.
I don't think so. No, good question. Yeah, this right up here has nothing to do with it.
Okay.
This up here does. And remember, is 10.
Okay.
Yeah, it's a great question. Good question, Chris. Now, when I do this now, I want to make sure that I could take now negative 1/2 or negative 0.5 to the 10th power. So we're just going to plug this in. Now, it's important to know how to plug it in. You want to make sure you do this part up here first. So 1 minus parenthesis, and I put even another parenthesis, negative 0.5 to the 10th power. And I got 0.999023437.5, okay? Then I'm going to multiply that by 12. You get 11.9882 and so on and so forth, okay? Now, from there, I'm going to then divide that by, well, 1 minus 1/2, 1 minus negative 1/2 is 3/2, or 1.5. So if I divide that by 1.5 there, I should get 7.99. Is that right? It's approximately what I got. So about 7.99 and some change. And again, I think on the actual problem here, it's 8.01. So big thing, again, showing work is big deal. Because again, at this point, again, all is well on that. No problem. If you're pretty doggone close to that, you're gonna come up with that right answer. So, yep, that's good to go. Questions on that? All right, I know I talked a lot. What about y'all? Do you have any questions for me? I know I went through a lot.
Just keep kind of going through it, so I probably have a lot more.
Oh, can you go over this like state number 8 on section 3, which is like state which the following statements are true or false. That kind of goes along with the convergence type deal.
Absolutely. Yeah, let's go over number 8. All right, give me the first one, Hunter.
Log 1 equals 0. It's just a big. It's a big.
Okay. What is the base of this?
0, 10.
If it doesn't have it, it's 10, right?
Yes.
So if 10 is shot over to make it an exponential form, right? Changing a log to exponential, I shoot the 10 over to get 1 equals 10 to the 0 power, right? What's 10 to the 0?
0. 1.
Anything to 0 power is 1, right? So 1 equals 1, therefore number 1 is true. All right? Now what about the next one? What is that next one? Is it?
E to the ln of x power equals x. I think it's pretty easy.
What one's that?
That just cancels and then x equals x. So it's
Bingo. Yep. ln and x are inverses of each other, so therefore they cancel out. What about this next one? 6?
6 log to the 6 to the log of 9. Yeah, like that.
Yeah, so if I had this right here equals 9, right? What would be the base here? Good. Is that true? It's not. It's not. If it was true, it would be this. Ready? Why? Because this base and the base of the exponent is the same. Therefore, this would cancel. Therefore, 9 would equal 9. Okay?
And the next one is easy. It's log 7, base 7 of 7 equals 1. That's true. So those cancel.
Yep, that's exactly right. Again, you could also shoot this 7 over to that side. Does 7 equal 7 to the first? Yes, it does. That is true. Okay?
Just make sure.
Yeah, you're good. What about number 10 there? Is that 10?
Yes. So
Makes sense.
X equals 7.2. The 7x minus 5.
What would we do with 16? Yeah, you can't divide by 2, right? You got to get like basis.
Yeah. So it'd be 2 to the 4.
Correct. These would cancel. Then you'd set 4 equal to 7x minus 5. Okay. I'm glad I hit that one. It's a good one. All right. Do y'all have any other questions at all? We went through vertical and horizontal asymptotes, but if you need me to go through it again, we can. Trying to just see.
Wait, how do you call it slant again?
Slant, yeah, remember slant is always where it's one greater on the top than the bottom. So if I had x cubed plus 2x squared minus 3 all over x squared plus 1, right?
Right.
First of all, let's do this. Could I do minus 1? That might be better. Can I factor the bottom out? No, I can't factor out the top out either. Hold up. I can't factor out the bottom, right? What would that be? X plus 1, x minus 1, right? So what are my vertical asymptotes?
Yeah, 1 minus 1.
Good. Horizontal? Do I have a horizontal here?
No, because it's 1.
Nice. Do I have a hole?
You can't factor it out.
Yeah, we're just going to assume no because right now I didn't give you one where we could really factor out in that way. We're going to assume no. Because the top is 1 greater than the bottom, okay, we know that because there's no horizontal, only when there's 1 greater on the top than the bottom, we could take the bottom and divide it into the top. Now, when I divide this out, again, I'd have to include an x, I'd have to include a 0x, and I would divide it, but whatever I got to the top would end up being my ultimate answer there. What's up, man?
Hey, what's going on?
Oh, man, just peachy. Looking fresh as always.
Yeah.
Love it. So this would be y equals some sort of line there.
Okay.
That makes sense, Chris?
Yeah.
So if I were to keep doing this, it'd actually be 0x here, right? It's be 0x, and I'm just doing it quick. So like I would get x here. X times x squared is x cubed plus 0x squared minus x. Change the signs of each, right? So this would be 2x squared plus x minus 3 because I'd bring this down. What times x squared equals 2x squared? It'd be 2, right? And then at this point, I stop there.
Okay.
I don't have to go any further because I don't need a remainder. I don't need any of that. My equation is x plus 2. That would be my slant.
So once you get to a point where it's like x plus 2, then you can stop.
Correct.
Okay.
Will you ever get something at the top that's x squared for a slant asymptote? Like when you divide it? No, you won't. And the reason why is because if you think about it, this is always 1 less
Sure.
than what's in here. Do you see what I'm saying? If this was like just x plus 1, this thing would be x squared. That wouldn't be a slant asymptote. What would it be? It'd be like a parabola looking thing. All right? It's just kind of weird, but I just want to make sure I went through it. All right? What about ellipses and all that jazz? We good on that stuff? I'm going to ask a question like, what's the foci of this? I'm going to ask that. I'm going to ask what's the...
Yeah, can you go over which foci formulas go with each?
Absolutely.
I always forget that. Like a squared plus b squared equals c squared, a squared minus b squared.
In fact, let's do this. Let's do this
Are you
one.
going to give us that, or are we going to have
It's a great question. Let me see. That's something I think you'll need to remember. You know what I mean? Yeah, you'll need to remember that. That's something. I think that's something I'm going to have you remember. You know what I mean? Because I don't think that that's a tough one. You know what I mean? Like I think if I were to do one like, let's say this, okay? I know that with an ellipse, it's a squared minus b squared equals c squared, right? Let's do the same one, except this time Let's do minus. Okay. This one is a squared plus b squared equals c squared. So what is a squared here? Remember, a squared is always the larger, right? 16? Yeah, so 16 minus 7 equals c squared, right? 16 minus 7 is 9, right? So 9 equals c squared. If I square rooted, what would c be equal to? Plus or minus 3, exactly. So plus or minus 3 is your c, right? We're going to come back to that in just a second. Come down to the bottom. This one would be 16 plus 7 equals c squared, right? Same thing. This is a hyperbola. This is an ellipse. So if you think about it, 16 plus 7 is 23. Square root, we'd have plus or minus square root of 23 for c. Now, the question that I have is, what's the center of these? What would be the center of this up here?
Oh, is it, it's -2. 3.
Good. Hunter, do you see that?
Yeah, the opposite.
Correct, for both of them, right? Now, which one up on top here for the ellipse would be transformed? Where would the foci always in for my vertex? Or I almost gave it away. For my ellipse. It's always inside my vertex, right? Or my major axis. So it's always inside. In this case, since the x has the greater, it's going to be inside the x. So where will I add and subtract 3? To the x or the y? Correct, because it's greater, right? Think about it this way. -2, 3, that's up here, right? So I'm going to be going 4 to the right, 4 to the left. Square root of 7 is like 2 point something. It's going to be like this, right? So that's why the foci are always inside. If you need to graph that, that's fine, okay? So then I'll...
Will the one with the bigger number, is that on, so that's always the major axis, right?
Correct. This is just for an ellipse, right?
Even if it doesn't come first, like, well, that would really make a difference, right?
Correct. It does not matter. Does not matter. Great question. So now go ahead,
When
Chris.
you draw the circle for the ellipse, it goes through the major axis points, right? And the foci.
Correct. Yeah, I didn't hit that, did I? Should go right here.
And for hyperbola, it's the foci are outside of it. Oh, no.
Correct. You're exactly right. So this right here would go 4 to the left, 4 to the right because of this, right?
Yeah.
So be right here. 1, 2, 3, 4. 4 to the left, 4 to the right. It'll go 2 up, 2 down, approximate 2 point something. So it's going to look like this, right? You know the asymptotes will go from corner to corner. Will this thing be graphed left, right, or up or down?
That's right.
Not because it's bigger, but because it's first. Remember? It's a little different than the last one. So it's going here. So when I add and subtract, it just so happens that this one will also be added, subtracted to the x. So plus, minus, square root of 23. Up here, we can actually add and subtract 3. So this should be 1, 3, and -5, 3. So these are my foci here. This is my foci here.
For hyperbola, the box ends at the end of the major axis, and you add the foci
To the center.
to the center.
Correct. It always comes from the center, but it just so happens that it is on the outside.
Okay.
Yep. Great question. Because remember, it's a squared plus b squared. So it's going to be a little bit greater than a squared minus b squared. All right, does that make sense? Do y'all think we need the foci formulas? You think that's a need?
You told me to review it a lot.
Wouldn't hurt.
Yeah, it wouldn't hurt.
Okay,
I mean, not
If you gave him a heads up before,
giving
like,
you the
you'll.
answers to that wouldn't hurt.
Yeah.
But, you know.
sure.
I just have a question on this.
Okay.
Graph.
Okay, I can do that.
For the z, how'd you try to zero this? I tried the second trace and go to 0. You go left bound this way, right?
Here, is that the one that has the long equation?
Yeah,
where you
it's
have
like -4x to the third plus 10x. It's like 5 of zeros.
Yeah, do this. Go to Zoom. Did you go to Zoom Fit?
Zoom. There you go. But it like doesn't move.
It's like right there, right?
Yeah.
I would test that one. And that one right there.
Okay.
So left bound, right bound.
So
That's
if you
what I
go
would
second
test.
Trace 0. So you go left bound. And it covers that. That's the issue.
What question was this again?
Number 2, I think, on the unit 2. It's in unit 2.
Let's see here. Give me. How do you get 2 and a negative 11?
Yeah, that's I was just trying to find that first 0 so we can keep going.
Yeah. What you could do, let's see, y equals.
Hey, Coach, I gotta get out of here. I gotta
You're fine, man.
I appreciate you doing this and everything.
Anytime, dude.
I'll definitely watch the rest of the podcast tomorrow.
Right on. Yeah, I'm guessing we're kind of starting to wrap it up. I think a lot of people's questions are. Yeah. Sam, how do you use this one?
I'll see you, Chris. See you
How's
soon.
it
All right, so here we go. Graph. What I would always go is like start at Zoom standard, okay? Okay. There he goes. Okay. So what we could do now is we could find one of them. Okay. Then what I do is I kind of go just a zoom out. Okay. Zoom out a little bit. Just try to zoom. Okay. Okay. That still didn't do anything. Then I go to zoom. Zoom fit. Okay. And then at this point, you know that there's one on that side, right? There's one right there. And then it goes up. You know what I mean? So I can go left bound, right bound. Then what I could do is I know I see there's one there. So what I could do is just go to my window and manually on my, just go to negative 20. Just try and do it 20. See what happens. It takes a little while. And that helps me. You see how I mess with it a little bit? There's not always maybe a cookie cutter way to do it every
They
time.
might have input it wrong. That came out. Mine would look like a parabola, but that's yeah.
Oh, I think that one's supposed to be positive x to the fourth.
Oh, I think it said okay. That might be what it was. Let me check.
I think that's right. Positive x to the fourth. Samo.
Question for you.
Oh yeah, that's what it was. Yeah, it was positive. That shit is it.
Yeah, that'll change it a little bit there.
I'm looking at number 8 on unit 1, and I'm about to factor this side, but I'm realizing it's going to be subtraction, just combine my terms.
Actually, no, you'll FOIL there.
Even
So
with the negative in the middle?
yeah, so multiply these.
Distribute the negative in.
Multiply those, then distribute the negative to the right side. Okay. Is that number 8?
Yes.
On unit what?
That
Again.
was like,
8 on unit
1.
1. Yes, number 8 on unit 1. Those at home, make sure that you look at that. You want to distribute. That one's going to be a really good one for the test because that one, remember, I talked about.
So we distribute the negative first or later on?
Distribute the negative last.
yeah.
So what we're talking about is,
Okay.
if I've got it here, what I would do is 3 minus 2i,
It was like this.
3 minus 2i.
Did that.
Okay, once I do that, I have 4 plus 3i,
And
4 plus 3i.
do that all the way down.
And then once I distribute this, right, I'll get like 16 plus 6i plus 9i squared, right?
Yeah.
What I'll do with this is distribute this negative in.
Take care of that I squared and then do another FOIL.
Yeah, you could take away that I squared before you do that, or you can wait. It's up to you.
Cool.
But that's what I would do, then distribute the negative inside. Okay? All right. Those at home, hopefully that was helpful for you. Again, you really want to focus in on the hyperbolas and ellipses. Check out previous podcasts from the previous section. Other than that, man, I hope you have a fantastic time. Hopefully you study hard and review. And again, if you have any other questions for me, there I am. There we go. If you have any other questions for me, please feel free. Contact me, email me, or come in Wednesday or Tuesday morning. This is Chris. Chris, you want to sign out?
Yeah.
That's just your thing.
I already signed off for the last time. I'm going to do it again. Signing off for Coach Jay, Catherine Stouffer, Sam Casey, Emily Woody. This is pre-cal. We're going to ace this exam, right? We're going to get 100, right? Yeah? No? All right, Sam? All right. Signing up for Precal. Go Spartans.
Please just hit the button. It's right. It just
Okay, all right, Sam.
just go Spartans.
I was going, you know, had a little flow there.
Well, you
All
want
right.
it's the thing. Is what
All
it
right,
is. It's,
okay, we're
it's,
hit the
we're
button.
gonna click it now.